Let's talk about the new space race, right above our heads. For decades, satellites were rare, expensive, and each had a single job. Now we're launching mega constellations, swarms of thousands of small, mass-produced satellites. Companies like SpaceX, OneWeb, and Amazon are racing to fill low Earth orbit with these networks. Their goal? Global high-speed internet, reaching even the most remote corners of the planet. To do this, they launch satellites in huge batches, sometimes 60 or more at a time. The numbers are staggering, from a few thousand satellites to tens of thousands, with plans for hundreds of thousands more. This isn't a gradual change, it's a rapid transformation of our immediate cosmic neighborhood. The lower orbits are now prime real estate, with corporations competing to build their networks first. The result? A sky that's getting more crowded every day. We're fundamentally changing the environment just a few hundred kilometers above Earth. Before 2019, humanity had launched about 9,000 objects into orbit. Today, a single company like SpaceX operates more satellites than that, and it's still growing. We're building a global infrastructure in space at breakneck speed. But with this construction boom, we have to ask, what are the consequences of building so much, so fast? We're venturing into uncharted territory, and the stakes are high. The promise is global connectivity. The risk? We may be creating problems we can't easily fix. The era of mega constellations is here. Are we ready for what comes next? Imagine a busy highway, except every car is moving at 17,500 miles per hour. That's low Earth orbit today. Satellites, rocket debris, even stray screws, all hurtling around the planet. A collision isn't just a crash, it's an explosion, creating thousands of new pieces of shrapnel. This is the space debris problem. The more we launch, the higher the risk of a catastrophic chain reaction, the Kessler Syndrome. One collision creates debris, which hits more satellites, creating even more debris, a runaway cascade that could make parts of orbit unusable for generations. We're not there yet, but near misses are increasing fast. Even a fleck of paint can destroy a satellite at these speeds. Mega constellations add tens of thousands of new satellites, each a potential source of debris. Satellites are designed to burn up at the end of their lives, but failures happen. A dead satellite becomes a zombie, a ticking time bomb in a crowded orbit. As we launch more, the odds of disaster rise. Space traffic controllers are overwhelmed, tracking thousands of objects. We're betting on perfect technology and management every time. But in space, one mistake can change everything. Are we prepared for the fallout? For millennia, the night sky has inspired wonder and discovery. Now, mega constellations are changing that view. Satellites reflect sunlight, appearing as bright streaks across the sky. For astronomers, these trails can ruin long exposure images, erasing faint galaxies and distant stars. Major observatories like the Vera C. Rubin Observatory are already struggling with satellite interference. Companies have tried solutions, darker paint, sunshades, but the problem persists. The satellites are most visible during key observation times, just after sunset and before sunrise. It's not just visible light, radio signals from these satellites interfere with radio astronomy too. This isn't a minor inconvenience, it's a threat to our ability to study the universe. The night sky is a shared heritage, connecting us to our past and future. By filling it with artificial stars, we risk losing that connection. Every image of the cosmos could be scarred by satellite trails. We're trading our view of the universe for better broadband. Is that a price we're willing to pay? The answer will shape our relationship with the cosmos. The environmental impact of mega constellations starts on Earth. Building thousands of satellites requires rare minerals, energy, and global supply chains. The carbon footprint of manufacturing on this scale is significant. Each rocket launch burns massive fuel, releasing pollutants into the upper atmosphere. Rocket emissions, though small compared to aviation, affect sensitive atmospheric layers in ways we don't fully understand. More launches mean more pollution in a fragile part of our planet's system. When satellites burn up at the end of their lives, they release fine metallic particles into the atmosphere. Scientists worry this could alter cloud formation or atmospheric chemistry. We're conducting a massive, uncontrolled experiment on our own atmosphere. The long-term consequences are unknown. We're industrializing space without a full environmental impact assessment. The promise of global connectivity comes with a hidden price tag. Are we ready to pay it? Space is becoming a crowded, lawless frontier. The main international law, the Outer Space Treaty, was written in 1967, long before mega constellations. It offers few rules for managing space traffic or preventing collisions. Each country licenses its own companies, creating a patchwork of regulations. There's no global authority to manage space traffic or enforce debris rules. The US military tracks debris, but even their systems are overwhelmed. Private companies now offer tracking services, but who's liable if something goes wrong? Without clear international laws, a major collision could spark legal chaos between companies and countries. We urgently need global agreements on space traffic, debris mitigation, and liability. But getting dozens of nations to agree is a monumental challenge. Meanwhile, launches continue and the sky grows ever more crowded. The rules haven't caught up with reality. Can we create order before chaos takes over? Space is the ultimate high ground, and mega constellations have huge military potential. Networks built for global internet can also control drones, guide missiles, and connect soldiers anywhere. The line between commercial and military assets is blurring. In Ukraine, Starlink became a vital tool for military operations, showing how private networks can shape conflicts. This gives private companies unprecedented influence and makes their networks military targets. Attacks on these satellites could cut off civilian internet and create dangerous debris. The rise of mega-constellations is fueling a new arms race in space. Nations are developing anti-satellite weapons, jammers, and cyber tools. Instead of making space peaceful, commercialization could make it more contested and dangerous. Low Earth orbit is becoming a potential battlefield, with civilian infrastructure at risk. The stakes have never been higher. Mega-constellations are a technological marvel with the power to connect billions. They could revolutionize education, healthcare, and economic opportunity worldwide. But this progress comes with profound risks: space debris, lost astronomical heritage, environmental unknowns, and military escalation. The problem isn't the technology, it's the speed and lack of foresight in its deployment. If we rush ahead, we risk turning low Earth orbit into a junkyard, cutting off future generations from space. We could lose our view of the stars and make space a new domain for conflict. The choice is ours: reckless expansion or responsible stewardship. We need global cooperation, enforceable rules, and a commitment to sustainability. Space must remain accessible and peaceful for all. The future isn't written yet, but the clock is ticking. Will we act with wisdom, or repeat the mistakes of the past? The era of mega constellations is here. It's up to us to shape what comes next.